Okay, so let's start with the first problem of lead code. From now onwards, I will only focus on problems and we'll discuss the theory through problems. Okay, so let's discuss the first problem of lead code using five approaches. Using five approaches. This includes from brute force to obviously better and to the best, which includes my code plus others code which I like. So from now on we'll study the DSA like this one using problems. Okay, for that reason let's start. Let me first read all this and we'll keep a track record of the problems that we're gonna solve in this class. So first, to solve. Okay, so let's discuss the first approach, which is like this. Obviously this is the brute force that we take. I'm not gonna use the rep because that's my macro when I do competitive programming. But for now, let's do just this for I to n minus one obviously, and then from for j from I, because we can't take the we don't need everything. We just in fact we don't need that element itself. We just need the element after that. What this question states you that you have to pick up two different elements from the array, whose sum makes the target value. Okay, target arr I arr j. Okay, so this is like a two pointer but brute force for now. So what this is what the problem states. So from j, which is I plus 1 to n minus 1 obviously. So in this code we do nothing but just for every arr I we choose arr j, which makes the target, and then return the answer. It's as simple as that. Okay, so return let me write it more clear. If arr I plus arr j, what happened? Arr j equal target return I comma j, else we do not require the condition of else, because it is sure. Okay, it is not sure. We may be we may have to return the empty vector too. Okay, so for that reason, okay, we now we will just create a vector, then we will push this and this. If this does not but push in the vector, then we will return the empty vector itself, and that will be our answer. Okay, so this was approach 1. Good, but obviously you're not gonna use this approach anywhere in your life. That's for sure, I can say. And still, if you do, then 2 lakhs package. So now let's come to another one. So now let's discuss the second approach, which is this. So this is what the I can say a better approach. Like what was this? This was approximately O n square. This gonna be O n log n. O n log n approach, and that's too because of sorting, and not also sorting, but this also. Actually, if I would name it, I would just say it approximately again O n square, because this is O n square and this is O n log n, so approximately this is O n square, but better O n square than this. This was complete loop traversal, but this is not complete loop traversal in every case. Okay, this is n into n by 2, so obviously better. So for now, let's not get deep into the complexity, and let's discuss the approach. So what does this approach says? So according to this, we will first take 3 pointers. That is, those are start, end, and mid. Then what we're gonna do is sort the array. Sort ARR. Okay. Then we'll run the loop from I equals to 0 to n minus 1. Okay. And in this loop, first we'll start from start pointer. That is st equals I plus 1, and end pointer will be the last pointer, that is nums dot size minus 1, and mid obviously will be the middle. Okay, so this is what st plus n minus st by 2, and till now you must have realized why we use this instead of directly using st plus end by 2. Okay, so these are how we give the pointers. Now what we can do is simply running again a loop, that is while st less than equals to end if nums I, that is this, plus nums mid. Okay, I can say this one is like binary search approach. If you will see, then this is like a binary search approach. Instead we just using this another loop and doing binary search on this. So if we try to think on how we can use the binary search on this two-sum problem, then we will realize that if we sort the array, then we get a monotonic function like this. Okay, not like this, but like this. Okay, we will get a monotonic function like this, and in this monotonic function we need to find the two numbers whose sum makes the target. It is what we need to do. So, and what does binary search says that if we can convert this target function into a predicate function, which is like this, or how how do you, some people use it like this, but mostly use it like this. Mostly not, I would say 99% people use it like this, predicate function. And if you use like this, I don't know why you do. Okay, so, and in this we get two things, that those are this and this. This is the place where we get the first true, that is we found our answer. And what will be the answer? Our answer will be when we found out the number. So how we can use that is, if we use nums I, okay, we use nums I plus something and target. If we get nums I plus something less than target, then we will keep it in this area. And if we get nums I plus this equals to, greater than or equals to the target, then we will put this in this area, and then we will find the first true. And when we get the first true, that will be our answer most probably. And if still, we will then verify that if nums I and this first true plus equals to target. If it is not, then we will return the empty vector, else we will return the answer. So yes, we can convert this function, monotonic function, into a predicate function by doing these optimization. Okay, so let me first make it a bit smaller and do it like this. If someone don't know what a predicate function is, they can refer to other videos. There are many videos on YouTube regarding predicate function. Okay, so what I need to do more, let's see. Okay, first we got this simply, like, let me explain it further. We'll do nothing but just this binary search thing. Okay, this is nothing but binary search. You can see we are doing nothing, and there is also a fixed template of binary search. We have to just follow that template. Everyone uses different template. My template is different. I will discuss in other videos. When I make a dedicated video regarding binary search, that will come also, because I have planned that to make a video regarding binary search, because for beginners binary search is considered as one of the toughest topics in DS. Like, what are the topics in DSA for beginners? First is the string algorithm, that is KMP, and second is this binary search. And these are tough topics, no question. Let's not go deep into this, and let's discuss the third approach. Let's discuss the third approach. Okay, wait a second. Let me do this. I think I need to make it more far. Okay, so yes, now we got our canvas again. So now let's discuss the third approach. Okay. Okay, wait a second. These things. Okay, so with the third approach, I must tell you that the third approach is not difficult in understanding the code, but yes, it is what I should say, because there are some advanced topics used in this code, like you can see here we have lambda function, but I have explained it as well. So let's try to understand this, because when you understand, you realize that this is much easier approach, which just solves using the time complexity O n log n. Okay, so let's discuss it. First, we will create a vector of pair and pair. Vector of pair, which will what this will store the numbers plus index, that is their indices. This will get stored in this vector of pairs. Okay, so now what we can do is just push back every single element with their indices in this vector of pairs. Then we will sort this, and this is nothing but a comparator function, like uh, what we know till now, that sorting is just simply a dot begin, a dot end, and it's over. Okay, but you don't know how this is working behind the scenes, like you really don't know what is a comparator. So what is a comparator? I can tell you with this, like here we write a comp. This is a comparator function, and the sorting algorithm will work as you guide in the comparator function. If you tell it to sort reverse, then it will sort reverse. If you say that don't sort the pair with a first element, like how does the original sorting function works, inbuilt sort function works with pairs, like they will sort first the first element, and if first elements are single, then they will go say same. If the first elements are same, then they will go to the second element and check which is smaller, and then it will sort. But with the comparator function we can change, like we don't want to sort it like this but want sort it like this, reverse. So we can do this, we can make a comparator function and we can simply do this. So here we made just a comparator function, which will we can understand it like this, which will return a dot first less than a dot b. So this is nothing but uh, let's see what this does. Okay, in a sorted array, indices I and mid represents a position in the sorted array, not the original unsorted array. Okay, so we know that indices I and mid is representing position in sorted array. Okay, so like here we simply what we did is sort the elements, and we don't have I like this now, that is I equals to 0 1 2 3, 4. We don't have like this because we have jumbled it after sorting. So we will first have the element, lowest element and its indices, for example 4, 1, 0, 3, like this, okay, 2. So we have like this, that is said here that indices I and mid represent the position in sorted array and not the unsorted array. If you push this indices directly into the result vector, you might end up with incorrect indices with respect to the original. Okay, so what does this says you? That if you will push these indices directly into the result vector, then you might end up with incorrect indices with respect to the original unsorted array. That is, if we push these indices into the vector, which vector we are talking about? We are talking about these. Like what we did here is first pushed everything, but here it is saying that if we first if we first push the elements and not their indices, like what we can't do here is that take two vectors, one will store the, we can't do like this. Let me mark it with red. We can't do this, that we make the two vectors, one will store the elements and second will store the indices. Okay, we can't do like this because when we will sort, we will not have the access directly to the indices. For example, do I have to give you example? You can understand it only. Okay, simply it will get jumbled and these are not jumbled, so both will not be corresponding to each other. Okay, so this is only what saying here, that we can't give these indices directly into the result in vector. Okay, so we first need to push both into the pair. To address this, you should find the original indices corresponding to the sorted value before pushing into the. This ensures that the result vector indices refer to the, yes, refer to the positions in the unsorted array in the corrected code. I use the second member of pairs in nums with indices to get origin. That's what I said here, that we're gonna use a vector of pairs and not two vectors, because one will get jumbled and other will be not jumbled, so these both will not correspond to each other. Okay, so let's begin further. And I have also told you the function of the comparator function. So now let's start again. This is nothing but just okay, I should not say that this one here is binary search, because we did quite a lot of things and it is not looking like a binary search first of all. So what we did is simply we created first the start and the end. Two pointers we created, this one starting with 0 and this one starting with n minus 1. So while this is less than this, we'll run a loop, and in this loop what we first do is, as we can see that these are sorted. So like this, first element plus last element will make something nearby target. because this is the lowest element, this is the highest element. So constituting both will get something in mid. So if target is in mid, then we'll simply push the both start and end and sort the indices before returning, and we'll return the result simply. It's over. And if the sum is lower than what we expected, then we understand that this element is low. So we will further increase the start pointer, and if we see that this is more than the target, then this last element is much bigger than what we want, then we'll simply move it backwards. Okay, so this is what the code is doing here, and at last we'll simply, if we not get any solution, then we'll simply return the empty vector. Okay, so this is what the total code was. Now let's discuss some more things that we have here. Okay, so the idea is to store each element with its present index. I have given you some examples also, or maybe these are the same code that I said. You can say I have also did this, commenting out things for you to understand it more clearly. So let's first read what the statement says. The idea is to store each element in the present index in a vector pair and then sort on the elements. Finally, print the element with its vector associated. Okay, so I have also did the same in the ChatGPT, and this is what the ChatGPT gave me explanation of the lambda function. A lambda function is an anonymous function defined directly within the sort function call. It provides a custom comparator. Yes, that's what I told you, a comparator function. That's also called the custom comparator function, or here what GPT uses the custom comparison function for sorting. The lambda function syntax is as follows. The lambda function takes two parameters a and b, which are both pairs of integers. It compares these pairs based on the first element, and the lambda returns to if the first element. The same thing. Combining both pointers, sort function uses the lambda function to compare integer on the based on their first elements. The custom comparison ensure that nums vector sorted based on the element from the origin vector names, and lambda function and the OK type help to achieve this sorting behavior. According to this, it is important. But I don't think that using the custom comparator function is important here. We could just sort the array and got the answer, because we can see here we are doing the same thing. Like here also, if we have two pairs, then we'll just simply return second pair first, and we'll simply return one if second pair first is greater than the first pair first, which is the same thing for sorting. Sorting also does the same thing. So I don't think that we really need the custom comparator function here. So let's move to the fourth approach. Okay, so let's open this. Okay, again we have this problem. Okay, so let's again think it like this. Like this is same code, and it is not better code, I would say. This is much slower than previous code, because it is again using that O and into n by 2. This is just increasing the complexity and not decreasing it. So you can think it like this: we did all the same thing until here, and then we simply did the binary search thing. Okay, we simply did nothing but we created two pointers that those are I, and we made, and we then again did the, like we did. This is a mixture of the third approach plus second approach, and giving the time complexity of second approach, which is not why I am writing this again, which is not much better. So you can read it. I have given you, but you must not use it. We have got a lot of things to study here and understand in this code, but using this code is not much efficient. Okay, so let's move further ahead. This is the correct code, as you can see here. And this is again a shortcut code. Like I had also written here the mentor Zindagi thing. This is short in nice but difficult in understanding or in time complexity also, because we are using the find function, and find function itself uses this uh, on thing. Okay, so I can say that we are using nothing but on square in this approach. So our best approach will be the third only. Use this third approach. These are just what we can understand from the code. Okay, so I am giving you 5 different approaches for the same problem, so we can understand it much better in every code. Like here what we did is simply creating a loop which will run from 0 to n minus 1, and just finding the complement, and complement target minus nums I. And what is this nums I? This is corresponding to this. And what is our target? Target is simply what we have given, and we found a complement. Now we will find this complement in the whole nums array, and if we found, we will simply return it to the auto it, that is iterator. And if we found that it, then simply we will push back I, and we'll push back this it. And see, we are using one important thing here, I would say, that is distance function. Using this distance function will give us this array index. Okay, so how are our arrays get indexed? 0, 1, 2, 3, 4, and further. But using this auto it, what we got, the iterator, that is this address of this index, which will be a hexadecimal code, XO6, and all around. So what this distance function does is that, think it like the auto it gave us, the iterator points at this in index and points at this index, not this index. So what we'll do to get 4, we'll simply find distance. Using the distance function, we'll simply find from nums dot begin, that is the address pointing to 0, to it, that is address pointing to this. So we'll find simply the distance, and we'll get 4 minus 0, which is 4, and we got this 4 index, as simple as that. And then we'll simply return the result. If we don't find it, after completing the whole loop, we'll simply return the empty vector, that is result. Okay. So in this video, what I gave you, the 5 approaches of two-sum problem, which is the first LeetCode problem.